Hello viewers, I am Pandit. Welcome to my YouTube channel. In this video, we will be discussing power electronic switches. By the end of this lecture, students will be able to list the properties of a switch, classify power electronic devices, draw symbols of power electronic switches, list power electronic switches or devices. Switch is an integral part of a power electronic converter. First of all, we will discuss the properties of ideal switch. In this diagram, we can see an ideal switch. Vs is the voltage across the switch and Is is the current flowing through the switch. Sign conventions given in this figure, we will be using the same sign conventions for all the other switches which we are going to discuss throughout this video. So what are the properties of the ideal switch? An ideal switch should be capable of carrying infinite amount of current in both forward as well as reverse direction without causing any damage to the switch. An ideal switch should be capable of blocking infinite amount of voltage in forward as well as reverse biased condition without causing any damage to the switch. Switching frequency. The ideal switch should be capable of operating at an infinite value of frequency. In case of a switch, when it is in conduction mode or it is in dynamic mode, that it is changing its state from on state to off state or off state to on state, during all these periods, losses occurring inside the ideal switch should be equal to 0. The ideal switch should be 100% reliable. Whenever the command is given to the switch, switch should operate, and when the command is not given to the switch, switch should not maloperate. About size and construction, the size of the switch should be as small as possible and the construction of the switch should be simple. If we are able to achieve all these properties in any of the switch, we can call that switch as an ideal switch. Power electronic switches can be classified into two main categories. First is controlled switches and second is uncontrolled switches. Controlled switches are those switches in which the turning on operation or turning off operation or both turning on and turning off operation can be controlled by some electrical or electronic mechanism. Uncontrolled switches are those switches in which both turning on and turning off operation cannot be controlled by any electrical or electronic mechanism. Controlled switches are further classified into two types. First type is thyristor. Thyristors are the family of devices. In thyristor family devices, mostly either turning on process is controlled or turning off process is controlled. Both processes are not controlled in case of thyristor family devices. Thus, these devices are usually called as semi-controlled devices. Though some exceptions are existing in these devices also. In type 2 devices, we are having gate-based commuting devices. In these devices, both the turning on and turning off operation of the device is controlled. Hence, these devices are usually referred as fully controlled devices. So our first device is silicon controlled rectifier or SCR. SCR is a unidirectional device. That means it can carry current in only one direction. Here it refers to direction of current is from anode to cathode, whereas SCR can block voltage in both the directions, that is forward as well as reverse direction. The turn on process of SCR can be controlled by giving a positive voltage to the gate with respect to cathode. But the turn off process of this particular switch cannot be controlled by giving any signal to the gate. Once the device is turned on, gate has got no control over the working of SCR. The characteristics of SCR are shown in this figure. Here we can see it is capable of blocking forward voltage as well as reverse voltage. But it can block forward as well as reverse voltage only up to a particular instant. This figure indicates the capabilities of SCR. Here we can see SCR can block forward voltage, SCR can also block reverse voltage. SCR can carry current in the forward direction, but SCR cannot carry current in the reverse direction. These values are limited up to the rating of that particular SCR. So our next device is bidirectional triode thyristor or Triac. As the name indicates, it's a bidirectional device. That means current can flow from terminal MT2 to MT1 or from terminal MT1 to MT2. This device can block the voltages in both forward as well as reverse direction. But we usually do not call voltages as forward bias or reverse bias in case of Triac, since it's a bidirectional device. Hence, we usually say voltages can be blocked when terminal MT2 is at a higher potential than MT1 or when the terminal MT1 is at higher potential than MT2. The turn on process of Triac can be controlled by giving signal to the gate terminal. But the turn off process of the Triac cannot be controlled by giving any signal to the gate terminal. As you can see from the VI characteristics of Triac, the VI characteristics of Triac are identical in first as well as third quadrant. So our next device is light activated SCR or LASCR. As the name suggests, it is a type of SCR. Hence, similar to SCR, this device is also a unidirectional device. It can carry current only from anode to cathode and not from cathode to anode. But it can block voltages in both forward as well as reverse direction. The specialty of this device is turning on process. The turn on process of this device is not with the help of gate signal but with the help of light signals. In further videos, we will be seeing the process of turn on of LASCR. The VI characteristics of LASCR are similar to that of VI characteristics of SCR. Silicon control switch or SCS. Silicon control switch is a unidirectional device. That means current will be flowing from anode to cathode and not from cathode to anode. Silicon control switch can block both forward as well as reverse voltages. The turn on process of silicon control switch can be controlled by giving electrical signal to the gate terminal, but the turn off process is not controlled. The VI characteristics of silicon control switch is somewhat similar to that of VI characteristics of SCR. Programmable unijunction transistor or PUT. PUT is a unidirectional device. It can block both forward and reverse voltage. The turn on process of the PUT can be controlled, but the turn off process is not controlled. The main application of PUT is in triggering circuits of SCR. Our next device is reverse conducting thyristor or RCT. RCT is a bidirectional device. That means it can conduct from anode to cathode or cathode to anode. But RCT can block voltages only in the forward direction. That means when anode is at higher potential with respect to cathode, only under this condition RCT can block the voltage. As you can see from the symbol of RCT, there is a diode which is connected in anti-parallel combination with the SCR. Whenever the device is forward biased, in this condition, the SCR will be able to block the forward voltage, and since the diode is reversed biased, diode would not be conducting. But when the device is under the reversed bias condition, we can say that the diode is forward biased and diode will start its conduction. The turn on process of the device can be controlled only under the forward biased condition. When the device is under reversed bias condition, the diode will be conducting immediately once it gets forward biased. We will not be able to control the conduction of the device under the reversed biased condition. Turn off process of the device, though it is turn off process of the device cannot be controlled in both forward biased condition or reverse biased condition. Bipolar junction transistor or BJT. BJT supports only unidirectional conduction. That means current can be conducted from collector to emitter. Also, BJT can block only forward voltages. That means when the collector is at a higher potential with respect to emitter, BJT can block the voltage. But the main advantage of BJT is a fully controlled device. Both turn on process and turn off process of BJT can be controlled by using base current. Whenever base current is given, BJT will start its conduction. Whenever the base current is removed, the BJT will stop its conduction. The VI characteristics of BJT are as shown in the figure. These VI characteristics can be divided into three different regions, namely active region, cutoff region, and saturation region. When we are going to use BJT as a power electronic switch, we will be working only in the saturation region and cutoff region. We will not be using the active region of the BJT. Active region of the BJT is mainly utilized for the amplification purpose. Metal oxide field effect transistor or MOSFET. MOSFET is a unidirectional device. It conducts only in one particular direction. It can block only forward voltages. Advantage of MOSFET is it is a fully controlled device. That means both turn on process and turn off process of the MOSFET are controlled with the help of gate to source voltage. The VI characteristics of MOSFET can be seen in the figure. These VI characteristics are similar to the VI characteristics of BJT, but the main difference is in case of MOSFET, the actuating signal is gate to source voltage, and in case of BJT, the actuating signal is base current. Hence, MOSFET is known as voltage control device and BJT is known as current control device. When we are going to use MOSFET in power electronic converters, we are going to utilize the MOSFET as a power electronic switch. So, from the characteristics, we will be using only saturation region characteristics and cutoff region characteristics. Active region characteristics would not be used for power electronic application. Insulated gate bipolar transistor or IGBT. IGBT allows only unidirectional conduction. IGBT can block voltages only under the forward biased condition. Similar to BJT and MOSFET, IGBT is also a fully controlled device. That means both turn on and turn off process of the IGBT can be controlled with the help of gate to emitter voltage. VI characteristics of IGBT are shown in the figure. Similar to MOSFET, IGBT is also a voltage controlled device. When we are going to use IGBT in a power electronic converter, we are going to utilize the saturation region and cutoff region of the characteristics. Active region of the characteristics would not be used in power electronics. IGBT has the advantages of both MOSFET as well as BJT. Gate turn-off thyristor or GTO. GTO is the device which allows conduction only in one direction, that is from anode to cathode. GTO can block voltages in both forward as well as reversed condition. Unlike other devices from the thyristor family, which can be turned on with the help of gate, and after turning on, gate loses control over the operation of the device. In case of GTO, both turn on process and turn off process can be controlled by using gate signal. In this discussion, we have seen properties of a switch, classification of power electronic switches, symbols of different power electronic switches, overview of characteristics of power electronics switches. These are some references which we have used for creating this presentation. Thank you. If you like this video, please do hit the like button, subscribe button and the bell icon so that you will be keep on getting the notification whenever we upload the new video. Thank you.